Rainwater. There's not much behind rainwater that we do not know about. We all know that it is water that falls from the sky. But do we all receive the same water? What we are trying to ask is what is the difference between the water that falls in rural areas as compared to the water that falls in the cities? Do the different areas have some kind of effect on the rainwater? Well, in order to answer that question, we will test the pHs. We will test the conductivity. We will test the nitrates, and we will test other certain chemical properties on the rainwater. We choose different areas throughout Dalton, and we have also chosen 2 outliers. With these locations, we will test and answer the question at hand.
I will place the jar in an open area so that it can catch the rainwater as it falls down.
This is Beck, and this is Andrea Garcia, and we're here to discuss the results of our IB project over water quality in different areas. We tested nitrates and water, leading to water quality and the effects on the environment, as well as pH
and conductivity.
I gathered water from many different places. We got some from Brookwood, Ringgold, Abston, Westwood, Dalton State, Roan, and Albert House. Right here's a map, and it shows all locations varied.
Here we have the LabQuest 2 that we're using to record data. The first utensil that we used was the conductivity, and here's the switch for you to use on that. The pH, and the pH right here, you can see it being detected. Here we have the dissolved oxygen. You can see it in a blue container. Okay. The dissolved water for cleaning the utensils such as the pH and the conductivity. And here we have the nitrate. And this is what we use to look for the nitrate. And here's an example.
Test 1, nitrate. So nitrate, there is no direct effect in rivers and streams on how much nitrate it takes to create a hazardous environment. Oh shoot. Okay, so there's no direct effect to water quality, although high and excess amounts of nitrate in streams can be hazardous to fish and aquatic life. Moving on. Okay. So for our nitrate test, we took our sample solution from each location, and we have nitrate tablets that we then dissolved into the water. It takes roughly 5 minutes to dissolve. Once this dissolves, it will create a color, and this is how we guided the levels of nitrate. It was qualitative, not quantitative. By the end of the test, we were around the 0 ppm to 5 ppm, and our data reflected that. We had 2s and 3s across the board, so there's not much variation. Nitrate is produced by fertilizers, the earth and soil. It's biotic, and so why we do not find much nitrate in precipitation is because it's not actually hitting the ground yet. We're just still in the atmosphere and we're catching it as it comes down. And so our nitrate levels were very low, and they masked with our control, which was specifically.
To test conductivity on the waters that we collected, we used a LabQuest 2 like we do for pH. And we used a conductivity probe. It has different settings, and we did ours around from 0 to 200 μs range. And most of ours turned out around, the highest one we had was around 250 μs, and the distilled water regular was 6.1 mUs. And to test it, all we have to do is turn it on and stick it in the water.
So here we got the pH probe. I'm gonna call it the pH probe because that's what it is. And basically, what you do is you make sure after you take it out of this container, you clean it out with distilled water, and ours is already clean. So basically, you just set it in here, give it about 30 seconds to a minute, and wait for it to change. And here's where you see the pH start to change. And like I said, give it about 30 seconds to a minute, and you start recording that data onto paper. And the highest that we have on here, ours was, I believe it was 6.8 from Brookwood, which is actually pretty good because it's very neutral. The lowest was Westwood at a 5.4. That's not really good because that means the water over there was really acidic. So just a heads up to that. Yeah, and that's all I got for you today.
Trying to find my peace in the zone of war. Even when the day comes, even when the day comes.
For this dissolved oxygen experiment, you will need a manganese sulfate solution, an alkaline potassium iodide as azide, a sulfamic acid powder, sodium thiosulfate, a starch indicator, a water sampling bottle, a titration tube and a titration tube cap, a syringe, a scoop, and a beaker of water.
To begin our experiment, we are going to submerge our water sample into our sampling. We will then, after removing the air bubbles, tightly cap the bottle and submerge it into our sample. We will then uncap our bottle and add 8 drops of manganese sulfate solution. We will then add 8 drops of alkaline potassium iodide. We then will cap our solution and mix. We will now allow the precipitate to settle. This will take 5 minutes. As you see, the precipitate is forming around the shoulders.
I don't wanna see us fall, so we just gotta keep on running. Even when the day comes calling, I'm ready too much. Even when the day comes, 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 I'll be ready when the day comes.
Now use a 1 gram spoon and add sulfamic acid powder to the mix. We will then cap the mix. And then mix it. And wait for it to dissolve. As you see, a chemical reaction is taking place. You will also notice the precipitate dissolving and becoming clear. We will then add the cap to our graduated test tube. We will then take our titrator and sodium disulfate and fill the titrator with sodium disulfate. We will then insert our titrator into our sample pool and release sodium bisulfate until our sample color is pale yellow. We will also stir as we insert more sodium bisulfate to properly ensure the bisulfate has reacted with our solution. At the point that our sample color is pale yellow, we will uninsert our titrator. We will then uncap our sample fluid and add 8 drops of a starch indicator. We will then slowly mix the starch indicator into our sample solution. We will now reinsert our titrator into the cap of our sample. At this point, we will continue to release sodium bisulfate into our sample solution while occasionally stirring. This titration will be continued until the blue color disappears and the solution is colorless. We then remove our titrator. The reading on the titrator will tell us the amount of dissolved oxygen in ppm. In this case, 8 ppm is the amount of dissolved oxygen in our distilled water.
Upon completion of our experimentation, we found several things to be evident. While the majority of the data gathered from the area and around the town was fairly stable, there were incidences of discrepancy in samples when tested in different areas. In one example, data gathered from Westwood, a neighborhood near the center of Dalton, was similar in all aspects of the other samples from Dalton, except that it was higher in pH, which is the most, and in which case this was the most acidic of all the samples. This could be a possible indication of higher levels of pollution in the area, or it could be a pocket carried over from the path which the storm took before coming to sit over Dalton. Another notable piece of data is that our 2 more rural sources also carried a large capacity for conduction. This in itself is rather odd, due to the fact that pure water does not tend to be a very potent conductor. This would lead one to believe that the water over this city would have a stronger capacity for current, as it would be more diluted by the pollution than the water found in the rural areas due to pollution. The fact that the opposite was true may indicate that there is some sort of chemical or particle within the solution that is inhibitory to the conduction of current. The one thing that we did not find to be largely constant in the values of our nitrate testing, which consistently resulted in 2 or 3 without any apparent tie to the area in which it was collected, thus implying that the nitrate value is relatively unaffected by the amount of pollution in the area.
Take out the papers and the trash. Or you don't get no spending cash.
That's not really good because that means the water.
If you don't serve that kitchen floor,
So, just a heads up to that.
you ain't gonna rock and roll no more. Yakety yak.
Don't go back.
Just finish cleaning up your room. Let's see that just fly with that broom.
Playing music.
Get all that garbage outside. Or you don't go outside at all. Yakety yak. You just put on your coat and hat and walk yourself to the laundromat.
Science.
And when you finish,
I'm pretty sure he's gonna cut out the noise in this.
yeah,
He's gonna cut me out right now. Hey Alex, what's up, bro?
Okay. Are you ready? I don't think you have to really. You can say whatever you want. They're not gonna see these. You don't have to say specifically. So you can just like use them like this one. Wherever it was, you can just say it was from here. It doesn't matter. Just label them.
So, do I just can start off with A?
You can start off however.
Dissolved oxygen.
No, wait, start now.
don't you give me
Sit down.
no dirty look.
For this,
Your father knows what cook.
It'll be a casual.
Just tell your hoodlum relax.
No, we're not taking pictures.
You ain't got time to take a ride. Yakety yak.
Don't go back.
Yakety yak.
I want you to just simply explain how we got or where we got all of our water from. So I want you to do that real quick. Andrea, please get out of the shot. Leave.
I am the shot.
No, you're not. You're about to get shot.
I'm ready for war. Coming to town and I'm high on the rise in the city of gold. Fighting the tide with my feelings aside when it's 2 in the night. The fire in my heart's gonna keep me alive and I'm ready for war. Ooh, oh, 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 oh. The voice in my head, hey, it's telling me that I should stay in my bed 'cause it's 2 in the night.